Hi guys, we're going to be starting chapter 6, which is going to be all about functions. So I just want to review with you really quick what it is to be a function. Just remember, we first saw functions when we were dealing with relations. A function is just a special kind of relation, all right? And I think its easiest definition is the fact that it's an input-output machine. You plug something into the function does something to that input, and then it shoots an output out. All right, it is defined to be a relation where each input has exactly one output. So when you plug a number into a function, only one number could ever come out for that input that you plugged in, okay? So to give you an example, they use this fancy function notation where it says f of x equals 2x plus 5. I just want you guys to remember that f is basically the name of the function. It's function f. X is the input that you'll be plugging in to this function f, and then the 2x plus 5 is basically the written rule that generates your outputs. He's the rule that this function has to follow, and he is what creates or generates all the outputs of the function. Okay? All right, so if you had f of x equals 2x plus 5, you could be asked questions like, well, find f of 4. Well, that means they want you to plug 4 into function f. So you would plug 4 in for x into this written rule. So f of 4 would be 2 times 4, not x, plus 5. And then it's an order of operations problems. We multiply first. 2 times 4 is 8. We add 5, and we get 13. So when 4 went into the function, 13 came out. So you could write it as an ordered pair. 4 went in, 13 came out, or you could say f of 4 equaled 13. When 4 went into function f, a 13 came out, okay? And that's how we worked with functions before. So again, you're just plugging something in and you're getting something out. So I feel like a function is only as difficult as his written rule. The more difficult this rule part is, the more difficult the function is. Well, in section 6.1, we're going to be working with operations of functions. So they're going to want you to add two functions together. They're going to want you to subtract one function from another function. They're going to want you to multiply two functions together, and then they're going to want you to divide two functions. Well, guys, adding and subtracting should literally feel like combining like terms. Multiplying should feel like you're foiling and distributing, and then division is going to be creating a fraction and then reducing that fraction. Okay, so here we go. So just get used to the notation they're going to use. If they're going to ask you to add two functions together, then they're going to ask you to find f plus g of x, which literally means take the f of x function and add it with the g of x function. And that's literally what you're going to do. You're going to take his rule and add it with his rule, and it should feel like you're combining like terms. All right, if they want you to subtract two functions, they're going to ask you to find f minus g of x. Now pay attention to the order. They want you to take the f of x function and subtract the g of x function from him. But you want to make sure that you subtract the entire g of x function. So a lot of times that will entail you distributing a negative, okay? All right, if they ask you to find f times, right, that's how we show multiplication with a closed dot, f times g of x, that means they want you to take the f of x function and times it with the g of x function. And that's probably going to feel like you're foiling or distributing, okay? And then if they want you to divide the two functions, they're going to ask you to find f divided by g of x. And that literally means to take the f of x function and divide it by the g of x function. And then you'll look at that basically fraction that you have created and look to see if you can reduce it, all right? But these are both notations that your book can use. So just know that if you're asked to do this, it means this. This is exactly, I like this form better. I feel like this form makes it a little bit clearer or a little more obvious as to what you're doing. All right, let's give it a whirl. Let's try some. Okay, so look at example 1. Let f of x equal this rule, equal this function, and let g of x equal this rule, okay? Perform the indicated operations. So in part A, they want you to find f plus g of x, all right? So that literally means to take the f of x function and add it with the g of x function. So guys, who represented the f of x function? this rule right here, 3x squared minus 2x minus 5. So take that, 3x squared minus 2x minus 5, and now you're going to add it with the g of x function. And who represented the g of x function? This rule right here, x plus 1. Now with adding, I don't have to worry about using parentheses or distributing because you're just going to add everything from that second function. And then all you have to do is go through and combine like terms. All right, so 3x squared plus no other x squareds is going to stay 3x squared. Minus 2x's, and then plus x is going to add up to, well, how many x's do you really have? If you take negative 2 and add 1, you have positive 1x. That's a, I'm sorry, no, it's not. It's a negative x. That's going to be a minus 1x, okay? And then you're going to take your number, negative 5, and you're going to add it with 1. And what number do you really have? Negative 4. And this is your new function for f plus g of x. And that's literally what you put as your answer. You don't even have to bring this down, just write this. I think you're gonna have to type it into Delta Math. So you just type this right into Delta Math as your answer, okay? All right, let's try some more. Let's try, all right, same two functions. We have f of x and g of x. Now they're gonna ask you to find f minus g of x. You have to be careful with subtraction because you wanna make sure you subtract all of the second function. All right, so if they ask you to do this, this literally means to take f, because he came first, of x, and minus the g of x function from him. So go get your f of x function. Who represented f of x? This rule right here. So 3x squared minus 2x, and then minus 5. Now we have to subtract the entire g of x function. So use parentheses to make sure that you subtract all of g of x. And who represented g of x? X plus 1. So what we're going to do is distribute our negative, and then we'll combine like terms. So 3x squared minus 2x minus 5, that's going to be minus x, and now minus 1. And now let's go through and combine. 3x squared and no other x squared is going to stay 3x squared. Negative 2x's minus 1 more x is going to be negative 3x, and then negative 5 minus 1 more is going to be negative 6 or minus 6. And that is your new function you get when you take f and minus g from him, okay? So again, it should just feel like combining like terms. All right, look at the next one. Now they want you to find f times g of x, all right? So that literally means they want you to take the f of x function and times him with the g of x function. Okay, well, go get f of x. Who was f of x? F of x was this rule right here, 3x squared, 3x squared minus 2x minus 5. We're going to take all of that and we're going to multiply it with all of g of x. And now who was the g of x function? That was x plus 1. So now the only way for me to multiply over all of this addition and subtraction is to distribute, right? So take 3x squared and multiply him with whatever's in the next parenthesis. So what's 3x squared times x? That's going to be 3x to the third, right? When we multiply, we add our exponents. All right, what's 3x squared times positive 1? That's positive 3x squared. Okay, since I have multiplied 3x squared with everything in the next parenthesis, I'm done with him. Now I distribute my negative 2x. So what's negative 2x times x? That's going to be negative 2x squared. Okay, what's negative 2x times positive 1? That's negative 2x. And now since I've times negative 2x with everything in the second parenthesis, I'm done with him. And now I distribute my negative 5. So what's negative 5 times x? Negative 5x. What's negative 5 times positive 1? Negative 5. And then you just combine like terms. All right, 3x to the third and no other x's to the third stays 3x to the third. If you have 3x squareds and you took away 2 more and no other ones, well, what do you have left? You have 1x squared left. All right, if you had negative 2x's and you took away 5 more, now you'd have negative 7x's. And then if negative 5 was your only number, he would just come down and stay the same. And this is your new function for what f times g of x would equal. You would just type this into your answer on Delta Math. All right, because that's what you're going to be doing your homework tonight. All right, the last one. Now they want you to take f divided by g of x, which literally means to take the f of x function and divide it by the g of x function. So if I do that, who was f of x? It was this function right here. So it would be 3x squared minus 2x minus 5, right? And now I have to divide that by g of x, which was x plus 1. Okay. Sometimes all you can do is create that fraction and be done. But because at the end of the day it is a fraction, we always want to reduce our fractions. But with all of this addition and subtraction in the way, I can't cancel anything on top or bottom and reduce it. I need things to be attached by multiplication. So now you need to factor your top and factor your bottom if you can, because remember how math works. I can't cancel out if I had, let's say, 3 plus 5 over 3 plus 4, right? Or let's say I had 3 times 5 divided by 3 times 4. Let's do that one first. If I had 3 times 5, that would be 15 over 3 times 4 is 12. And then we reduce it. Well, what's the biggest number that divides evenly into 15 and 12? It would be 3. 15 divided by 3 is 5. 12 divided by 3 is 4. So the answer to this is 5/4. But if you go back, because you are multiplying and you had 3 times 5 and 3 times 4, I'm allowed to divide first. I could do 3 divided by 3, which is 1 and cancels, and be left with 5 over 4, which is easier to do, right? That still is the same answer. It doesn't change. So when things are attached by multiplication, I can divide them out first and it doesn't change my answer. But addition and subtraction don't work like that. If I do this problem, 3 plus 5 is 8. 3 plus 4 is 7. If I tried to cancel my 3's now when they're attached by addition, 5 over 4 isn't the same answer as 8 over 7. So it doesn't work with adding and subtracting, which is why you have to factor first, get things attached by multiplication before you actually cancel them on top or bottom. All right, so if I factor this, look for a GCF, difference of two squares. It isn't anything, it's not grouping. I can go, well, what times what gets me 3x squared? A 3x and a 1x, and then what multiplies to 5 and gets my rainbows to get me that -2? Well, if I put a 5 here and a 1 there, I'll get 5x's and 3x's. I would need a minus and a plus to get me my -2x's in the middle. All right, over x plus 1, he doesn't have a GCF and he doesn't factor because he's linear other than a GCF, so he stays the same. And now what happens to a factor of x plus 1 on the bottom and a factor of x plus 1 on top? They cancel because they're attached by multiplication, and I can divide them out first. And now you're left with 3x minus 5 as your answer. So again, this answer isn't wrong. He's just not simplified. So you look to factor and cancel to reduce your fraction. Sometimes it doesn't factor and nothing cancels, and you'll just literally be left with that as your answer. But we always look to factor to see if anything divides out and reduces. So this would be your simplified finished answer. Okay? All right, let me give you 2 new functions and try it one more time, and then you should be good. Okay, so look here. Here is 2 new functions. We have f of x equals 3x squared plus 7x, and we have g of x equals 2x squared minus x minus 1. All right, first things first, they want you to do f plus g of x, which literally means to add them together. Take the f of x function and add it with the g of x function. All right, so who was f of x? This rule right here. So 3x squared plus 7x. And now we're going to add it with g of x, which was this part right here. So 2x squared minus x minus 1, right? Remember, with adding, you're fine. You don't have to worry about using parentheses. You're just adding it all together anyway. All right, so let's combine like terms. 3x squareds plus 2x squareds get you 5x squareds. And now 7x's, take away 1x gets you 6x's, and -1 is the only just number, so it'll stay -1. And that is your new function for what f plus g of x is equal to. Okay? Well, look here, be careful, because now they've asked you to find g minus f of x. The order does matter. So now they want me to literally find g of x, subtract all of f of x. All right, so go get g of x. G of x was this one right here, 2x squared minus x minus 1. And now I have to subtract all of f of x, which was 3x squared plus 7x. Okay. All right, so now I have to distribute my negative, and then I'll combine like terms. All right, so I have 2x squared minus x minus 1 minus 3x squared, and then minus 7x. All right, well, if you take 2x squareds and subtract 3x squareds, now you have negative 1x squared. All right, then you had negative x, and you took away 7 more, so that's now negative 8x's. And then if negative 1 is your only number, then he just stays negative 1. And that is your answer to what g minus f of x is equal to. So again, please make sure you watch to figure out if you're doing g minus f or f minus g or whatever letter they use. Order will matter with subtraction. All right, now they want you in part C to find f times g of x. So now that literally means to take the f of x function and times it with the g of x function. Okay, oh, sorry, I think I was off the camera. All right, so go get f of x. Who was f of x? F of x was 3x squared plus 7x. Okay, and then we're going to multiply all of him with all of g of x. So go get g of x. G of x was 2x squared minus x minus 1. 2x squared minus x minus 1. Watch your signs, right? We don't want to do this all for nothing. All right, and then again, in order to multiply over all of this addition and subtraction, we have to distribute and like do a big FOIL. All right, so what's 3x squared times 2x squared? That's going to be 6x to the 4th, right? We add exponents when we are multiplying. So now we have 3x squared times negative x. That's negative 3x to the 3rd. All right, 3x squared times negative 1 is negative 3x squared. Okay, I've multiplied him with everything over here, so I'm done with him. Now I have to distribute my 7x's. So 7x times 2x squared is positive 14x to the 3rd. All right, positive 7 times negative x is negative 7x squared. And then positive 7 times negative 1 is negative 7x's. All right, let's combine like terms. So 6x to the 4th and no other x's to the 4th stays the same, 6x to the 4th. Negative 3 x's to the 3rd plus 14 x's to the 3rd is now going to be 11 x's to the 3rd. All right, if I had negative 3x squared and I took away 7 more, now I have negative 10x squared. And then if negative 7x's are the only x's you have, then he just comes down and stays the same. And that's what you would get for f times g of x. That is your new expression there. Okay, all right, one more. Same two functions. Last operation is g divided by f, which literally means to take the g of x function and divide it by the f of x function. We'll go get g of x. G of x, oops, don't need that on the screen. G of x was 2x squared minus x minus 1, 2x squared minus x minus 1 over f of x, which was 3x squared plus 7x. Okay, so again, that is g divided by f, but it's a fraction, so we want to look to see if it reduces. I can only reduce it and cancel things out if things are attached by multiplication. So all of this subtraction and addition is killing us. So let's see if anything factors. So factor the top, let's see if it does. There's no GCF. I'm going to go with what times what gets me 2x squared is a 2x and a 1x. The only things that multiply to 1 are 1 and 1. And I need a negative x in the middle. So 1x and 2x, well, if I made this negative and this positive, negative 2x's and positive 1x add up to negative 1x. And then if I factor the bottom, well, first look for a GCF. They have an x in common, and then that would leave me with 3x plus 7. This would only factor, again, this linear factor is if you missed part of his GCF, but we didn't. So now since nothing matches on top and bottom, nothing cancels. So you could say this is your answer, or you could say this is your answer because nothing reduced or canceled, so either one is just as correct, okay? But again, you should always be looking to factor and reduce if it's possible, all right? Okay, so you're gonna do homework tonight on the website deltamath.com, where you signed up for next week. It'll be all in your Google Classroom assignment, all right? Please text me if you have any questions on any of this, okay? We will be taking a quiz on Thursday before spring break, okay? There will be a quiz on Thursday, just to give you guys a heads up on section 6.1, okay? All right, please text me if you have questions. I am here to help you. Good luck.